Welcome back. We're continuing Module 3, Topic 2, Lesson 3. We're on Activity 2 on page 426. Habits of mind, reason abstractly and quantitatively, construct viable arguments, and critique the reasoning of others. Making sense of multiplication equations. Multiplication equations often include numbers other than whole numbers. Consider the equation 1/3 x equals 2. So now we're going to move on to some fractions. And over here on the side, I want to focus in on, it says, remember, there are different ways to write equivalent expressions. So 1/3 with an x beside it is the same as x over 3. Because remember, next to the x is really a 1. So that is the same as this. I need you to either highlight or circle, draw an arrow to star, do something with this. It's important. Okay, so explain how the variable term in this equation compares to the variable term in the previous activity. So how does this one compare? In the previous activity, I believe we had a whole number with the variable term. Previously, the coefficient of the variable term. Notice how it uses the word of, which means multiply, and we do multiply the coefficient times the variable. Previously, the coefficient of the variable term was a whole number. Now it's a fraction. Pause if you need to. I'm going to continue on. Worked example. It says, consider the equation that states for some value of x, the expression 1/3 x is equal to 2. So we have this multiplication equation, 1/3 x equals 2. This equation states this. So one way to solve this equation for x is to compose, not decompose, but compose. Now we're going to add on to 3 distances equal to 1/3 x to create the distance of x. And that makes sense, right? So 1/3, we do 3 equal distances of thirds. 1/3, 2/3, 3/3 gives us 1 whole, right? 3/3, which equals 1. So we're going to compose 3 equal distances that are a third distance. This distance is a 1/3 distance. So we're going to do another one that's a 1/3 distance. So this will be the second 1/3 distance, so 2/3. And this will be the third. And we're going to actually just call that x. And on the other side, if our distance from here to here is 2, and we have an equal distance, which I didn't draw it very equally, but that's okay, you understand. So if our distance here is 2, then we need another 2, so we'd be at 4, and another 2 at 6. Okay, so I wanted to show that to you, how I constructed it, and that is what they show here. It says then one way to solve this equation is to compose, I'm just going to read this again, 3 distances equal to 1/3 x to create the distance of x. Then to maintain equivalence, compose 3 distances equal to 2. So we have 1/3 x, 2/3 x, just the x, so 2, 4, and 6. And it says complete the worked example by filling in the unknown values. We did that. Then write the solution to the equation 1/3 x equals 2. So if we have 1/3 x equals 2, what does x equal? So x equals 6. It wants us to check it. So if we do 1/3, substituting our 6 in for the x, 1/3 times 6, I'm going to put it over 1 since we have a coefficient that's a fraction, equals 2. 1 times 6 is 6. 3 times 1 is 3, equals 2. 6 divided by 3 is 2. 2 does equal 2. Checks out. Think about, because you start with a fractional amount of x, you have to compose to get a whole x. Okay, moving on. Page 427. Compose the distance of the variable term into the appropriate equal parts to determine the location of x. So now we have 1/4 size distances for x. So if we break this into fourths, this tells us how many parts we are going to set up our double number line into. So 4. So here we would have 1/4. Another 1/4 would be 2/4, 3/4, and then 4/4, which is just x. And on the other side, if we know 1/4 x equals 7, then our distances on this side of the double number line increase by 7. So we would have 7, 14, 21, and 28. So we have x equals 28. Okay, and then we need to substitute 28 back in here for the x. So 1/4 times 28 should equal 7. We have 1 times 28, which is 28. 4 times 1, which is 4, equals 7. And then 28 divided by 4 is 7, which does equal 7. And it checks. Okay, number 4. 1/2 x equals 5. Okay, so if this is half, right, I have it halfway, then this would be the whole way. Half of x, then just x. 1/2 x is 5. If we're increasing by 5s down here, we would have 10. So we have x equals 10 as our solution. I'm going to do the check up here. So we have 1/2 times x equals 5. Substituting our solution, the 10 for the x. 1/2 of 10, going to put it over a 1, equals 5. 1 times 10 is 10. 2 times 1 is 2. 10 divided by 2 is 5, and it does equal 5, and it checks out. I didn't connect my barbells. Okay, next one, number 5, says, Vanessa used a double number line to solve 4x equals 12. Analyze her strategy. So she says, I created my double number line and represented the equation nx. Then I labeled the bottom number line of numbers to identify the value of x. Okay, so let's see what she did. So it looks like she divided it into 7 equal parts. So 1, 2, 3, 4. Wait, I'm sorry. 1, 2, 3, 4. Oh, I'm sorry. They're starting 0 here. I was thinking they had 0 back here, so I am wrong. 1, 2, 3, 4, 5, 6, 7. So 7/7 would be the same as 1. So there's your 1x. And then down here, she knew that between 0 and 12, because it said 4/7 x equals 12, so she put the 12 here. So between the 0 and 12, there was 1, 2, 3, 4 tick marks. So 12 divided by 4 told her that it had increments of 3. The intervals went up by 3. 3, 6, 9, 12, 15, 18, 21. So she got x equals 21. So why did she set it up this way? The denominator of the coefficient is 7, so she composed it into, composed it into 7 equal size parts. Identify and check her solution. So she has x equals 21. So the original equation was this: 4/7 x equals 12. 4/7 x equals 12. and she had the solution of x equals 21. So we're going to substitute the 21 in for the x. 4/7 times 21 equals 12. 4 times 21 is 84. 7 times 1 is 7. And if you're not sure if 84 divided by 7 is actually 12, you should check it. So 84 divided by 7. 7 goes into 8 one time. 1 times 7 is 7. Subtract, I get a 1. Bring down my 4. How many groups of 7 can I get out of 14? 2. 7 times 2 is 14. So it is in fact 12. So 12 equals 12. It checks. That means, this checking means x equals 21 is correct. Use Vanessa strategy and the double number line to solve each equation. Okay, so number 6. You pause and try these on your own. I honestly want you to try them on your own and then come back and check your work. Okay, so it says 4/5 x equals 12. So I know I'm breaking it into sections of 5. So I'm doing it to fifths, so to speak. Okay, so 1, 2, 3, 4, 5. And connect them. That shows that they are equal. And the fourth one of these fifths is 12. So 1, 2, 3, 4. Here's 4/5. And it equals 12. Okay, so this is 1/4, 2/4. I'm sorry, 1/5, 2/5, 3/5, 4/5, 5/5 are just x. Between 0 and 12, we have 1, 2, 3, 4 intervals. So 12 divided by 4 is 3, so it's counting up by 3s. 3, 6, 9, 12, 15. So we get x equals 15 as our solution right here. And then we need to check it. So 4/5 times 15 should equal 12. So 4 times 15 is 60. 5 times 1 is 5. 60 divided by 5, I think of 60 minutes on a clock. If I count by 5s, it does take me to the number 12 on the clock. So 12 equals 12. It checks. That means x equals 15 is the correct answer. Okay, number 7. We are composing this into groups of 4. So let me go here. I'm going to do half first. And then I'll break this one in half. And then this one. So we have 1/4 x, 2/4 x, 3/4 x, and we finally get 2 4/4 or just the x. And 3/4 x equals 8. So at the 3/4 I put in 8. Now we have this broken up between 0 and 8 is 3. 8 doesn't divide evenly by 3. I get a decimal. So instead of doing that, I'm going to write it like this. I'm going to write 8/3, 16/3. This would be 24/3, which is the same as 8. And then another 8 would be 32/3. So I'm counting it up by values of 8, 8/3, 16/3. 16 plus 8 is 24, 24/3, which equals 8, and then 32/3. So in this one, x equals 32/3. And I know that seems odd, but let's check it. So 3/4 x, so 3/4, I'll rewrite the whole thing here. X equals 8. So 3/4, substituting in 32/3 equals 8. Now, some of you may see the 3's on the diagonal that we could cancel out, and they would equal 1, leaving us 32/4, which is 8. Some of you I know are still struggling to see that, so 32 times 3 is 96, divided by 12. And let's just check to see if it is 8. So let me do over here, do 12 times 8. 8 times 2 is 16, carry a 1. 8 times 1 is 8, plus 1 is 96. So 96 divided by 12 is 8, equals 8. So it checks out, which means x equals 32/3 is the correct answer. Think about the relationship between the algebraic expression and the constant. Will the unknown value be greater than or less than the constant? Okay, so moving on. 8/5 x equals 64. I'm going to switch colors. We have a lot going on here. Okay, so I'm going to divide it into fifths, but I need to go out to 8 of the fifths. Okay, so it looks like I'm going to go beyond the 5/5, beyond the whole. So let's see if I can divide this into fifths. So 1/5 x, 2/5 x. I'm not going to have room to write all these. So here would be 3/5. Here's 4/5, so I'm going to write this one in. So know that the 3/5 is in there. 5/5 x, so here's just x. After 5/5 is 6/5. 7/5 and 8/5 x. And they're telling us 8/5 x equals 64. So how many sections do I have this broken into? It should be 8. 1, 2, 3, 4, 5, 6, 7, 8. So 64 divided by 8 means this is counting up by 8s. So 8, 16, 24, 32, 40, 48, 56, and 64. I can fit the 7/5 in here. And this one right here is 3/5. If you can't fit them in, that's okay. The ones that we need to worry about are, this one are 8/5 that we started with, and then our x value, so x equals 40. So we need to check that. They don't give us much room to check that, but let's squeeze it in over here. So 8/5 x equals 64. So we have 8/5 times 40 equals 64. 8 times 40, so 8 times 4 is 32, so 10 times more than that. 8 times 40 is 320. 5 times 1 is 5. So let's check that. 320 divided by 5. How many whole groups of 5 can I get out of 32? I could get 6. 6 times 5 is 30. Subtract, I get 2. Bring down the 0. I can get 4 whole groups of 5 out of 20. So my answer is, in fact, 64. So I get 64 equals 64. That checks. It means that my answer of x equals 40 is accurate. Number 9 says, reflect on the equations you solved in this activity. How were they similar? What was common? And how you used the double number line. So they all had fractional coefficients. For all of them, I had to think about how many equal distances there were, right? How many equal distances there were in the whole distance like up to the 1x. Okay, pause if you need to finish that. We'll see you on the next video.